Okay, guys, in this video, what we're going to do is talk about reflections, and we're going to show you how we can use the Stencil Buffer in OpenGL to add reflections into your applications. Now, we must begin with the question, what exactly are reflections?
Have you ever looked in a mirror before?
No.
No?
Yes, I have, obviously. And some people, like Joel, spend a lot of time in front of the mirror.
Hours, in fact.
They've got to make sure they look beautiful.
And sexy.
And what are they staring at? They're staring at a reflection of themselves.
Mm-hmm.
Okay? That's that simple. We all know what reflections are. Come on,
Right.
guys. If you're walking around on a highly polished floor and you look down, you see yourself, you see other objects around you in your environment reflected in that floor, that's a reflection. Now, our goal, of course, is to create real-time applications using OpenGL. Well, now suddenly reflections pose a bit of a problem.
They do, because, well, OpenGL and other real-time applications, real-time 3D APIs, don't support that.
And GL enable. Reflections. GL reflections. Woohoo! Wouldn't that be great?
That would be awesome.
OpenGL version 3.5 will have that.
Really?
Yeah, a secret man told me about it. Wouldn't that be nice?
That would be nice.
I'm sure that is coming one day. I wouldn't be surprised.
Yeah, but, if you're using ray tracing techniques.
Then you can get real-time reflections, refractions, but
not real-time.
Hang on. If you have a super-duper supercomputer.
Yes, 50 processors
only available
together.
in Japan. And you must have a $10 million budget.
No kidding.
For one processor.
That's right.
Exactly. So, yeah, the ray tracing, real-time ray tracing, is only for the rich kids, right?
Mm-hmm.
It's for those, I've seen equipment that will allow real-time ray tracing at SIGGRAPH and other places. But usually it comes with a price tag that's so big that if you have to ask, you definitely can't afford it.
That's right.
But, so we can't afford stuff like that. And our users out there that will be utilizing the applications that we write aren't going to have that kind of equipment either. So how do we go about adding reflections into our applications? We want things to look nice and polished and shiny and, reflect objects in it. And to pull it off, what we're going to do is we're going to introduce you guys to a trick or a hack, if you will. It's in a way to basically create an illusion that there's a reflection.
Very realistic illusion.
A very realistic illusion. And don't think that all because we said trick/hack that we're showing you something that no one else does because we're taking the cheesy way out. That's not the case.
No, not at all. This is actually used a lot.
That's right. This is actually very commonly used. Let's go and advance to the next scene. All right, here we go. Workflow of the creation of reflections using the Stencil Buffer.
Right.
Now, first thing to keep in mind, there's obviously all sorts of hacks, if you will, for creating reflections in your scene.
Or variations of this technique or whatever.
Yes, again, so many different approaches. That's all I want to get across. And we don't want to create an entire VTM series on how to add reflections to your applications. Our job is to show you guys at least one approach for getting reflections into your applications. Right now, if you look at that first picture right there, we got final result. And Joel, I'm telling you, it looks like we got a shiny floor that's reflecting that floating cube in it.
Yes, we do.
That's exactly what it looks like.
That's right.
But check it out.
Yeah.
That's not the case.
Not at all.
Check it out, guys. Here's what's going on. So what you're seeing is what looks like a cube and a floor, and the floor is reflecting. What's really going on is we've drawn the cube twice. We've drawn it here, and we've drawn it here, but this one, the cube has been transformed with a scale of -1 in the y-axis. It's been mirrored across the floor plane right here. And now, with that being the case, you may be thinking to yourself, why isn't the whole cube being shown? Ooh, this cool thing known as the Stencil Buffer is allowing us to cut off anything that goes outside of this plane right here because of a mask that we generate and store in the Stencil Buffer, which we're about to talk about in a second. Some of you guys have probably already started looking at it down over here. But utilizing that, the nice thing about this is anything that needs to be reflected, but for whatever reason, since we're doing this with a scaling, mirroring operation, ends up, outside of our reflected object area, if that makes sense. It's just simply not drawn to the frame buffer.
Right.
It's not there.
Right. If we had a little bit of the cube sticking out underneath the plane, it would look totally unrealistic.
That's right. Yeah, exactly. I just realized what it was you said. I'm like, yeah, very much so. Because this floor right here, once we've taken this object, mirrored it, and drawn it, so it's basically upside down down here, the same distance away from the floor that this cube is from the floor, okay? Then we drew the floor, and we simply made the floor transparent, slightly transparent. That's really cool, too, because the more transparent the floor is, the more it appears to be reflective.
Exactly.
So we can use transparency as a control for reflectivity of the reflective object.
Right.
reflecting object. Reflective. Interesting. So anyways, that is the trick we want to do. And the result is fantastic, as you can see here. But again, in this particular case, we're doing something that works great when we're dealing with flat planes, like a character that's running along a floor within a first-person shooter, and you can have a nice reflective floor. But you may be thinking to yourself, well, nowadays, 3D first-person shooter games, you can have hallways stacked on top of other hallways. So if I look down and I see myself reflective because all I've done is drawn my character mirrored in the other direction, why don't I see the top of the hallway below me?
Right.
Well, because there's techniques that allow us to control when we want to draw geometry and when we don't.
Right.
Maybe we just put a black plane in there that we can't see through. Or maybe we just have some very smart optimization in place that simply says, there's no way if I'm standing in this hallway that I can possibly see the hallway before, because that's a waste of CPU time.
Right.
Because I shouldn't be in that zone or that area or whatever.
Right.
So in this particular case, then if you look down, you're looking at a transparent floor, meaning you're seeing out into outer space, if you will. You're seeing your reflection, and the user just simply says, hey, that's a reflective floor, and that looks nice.
That's right.
That's all that's going on. So in pulling this off, step one is to generate the mask. This is very important.
Very, very important.
When we go to draw our reflected object being reflected, that needs to basically only be drawn inside the reflected object area.
Right. I mean,
which in this case, the reflected object, that's the floor.
Right.
Okay, just so no one gets confused with the way I'm explaining this. So if that cube was to go outside the floor, and in this case, with the angle that we have our floor at, the cube obviously would stick down here below the floor. Our mask is responsible for controlling if pixels will or will not be drawn. In this case, you can see how it did a nice job of controlling all these pixels being drawn for the cube, but when we tried to draw the parts that came down here, those simply didn't get drawn at all.
Exactly. And to do this, we simply created a stencil buffer that has two pieces of information, on and off.
Ooh, a 1-bit stencil buffer.
Exactly.
Boy, that's hard stuff there.
Very difficult.
And think about it. With a mask, that's all a mask is. For those of you that aren't familiar with Photoshop or any other type of 2D graphical applications or 3D graphical applications like Maya or Max, a mask allows you to mask out certain parts of an image.
Right.
So we can let certain things show through while cutting out other things.
Exactly.
And masks are used in so many different things. And you can see how they're very helpful for us here. So we generate this mask in the stencil buffer. All we need is the color white or the color black. Will it draw? Will it not draw?
Exactly.
Period.
So once we have that set,
now
we need to go ahead and draw the reflected object.
That's right.
So simply take the cube that we have, reflect it along the y-axis in this case.
So just mirror it.
Mirror it across. Then go ahead and draw it.
And since
while
it's mirrored,
keeping in mind the stencil buffer is there, and so only drawing to the white areas of the stencil buffer.
That's right. And since it's mirrored, of course, it's got all of its textures and everything else.
The lighting information.
Exactly.
Everything.
And what's really cool is, so the cube right there, the bottom side of the cube, of course, when it gets mirrored over, since we're doing a scale -1, that's the transformation we're going to apply in the y-axis.
Right.
That's going to make sure that we're looking at the bottom side now looking up at us.
Exactly.
Which, again, helps further push that illusion of this is being reflected.
Precisely. So once we have that, we have our little cube, our reflected cube. Now
only what needs to be drawn.
Only what needs to be drawn.
Now we move on to step 3.
Step 3, draw the reflective
floor.
object. Get the floor.
Draw the floor.
And again, this is so simple because all we need to do is draw the floor slightly transparent, and then, well, the cube is going to show through it.
Yeah, you want to have a little fun after we get done with the application in the next video. Add a slider in that allows you to control how transparent the floor is.
And then, bink, it seems like we're modifying the reflectivity of that floor.
Exactly. It's like, well, check it out. It's like a complete mirror.
Yep.
Wow. Whoop. It's not a complete mirror no more. I can barely see it. And again, it's an illusion, but it's a very strong illusion, and that's really cool.
Yeah.
And so after we get finished drawing our slightly transparent floor, the final step is to go ahead and draw the remaining geometry that's being reflected.
Exactly.
In our case, it's just a cube.
Yep. So once that's done, you're done.
Yeah, we've got a reflective object.
Completely reflective.
So in doing this, what we need to understand is how the stencil buffer is used.
Right.
Yeah.
This is kind of important.
Stencil buffer. You've heard of all sorts of buffers as we've progressed through the OpenGL VTM.
Right. When we did the anti-aliasing, we talked about the accumulation buffer. We talked about sampling buffers, etc.
Talked about back buffers, frame buffers, now
everything.
Stencil buffers.
And in this case, much like in the anti-aliasing level, we said you had to create your buffers before you set the video.
Anti-aliasing lesson.
Did I say level?
Yeah.
Wow.
We're talking about games now.
So what we need to do is set up a stencil buffer before we actually set our video mode.
That's right. That's a must.
And in this case, I mean, you don't have to have a 1-bit stencil buffer that
Yeah,
just has on and off. You can have an 8-bit, whatever you want.
But all we need right now is that zero and 1 information.
That's right. So the first thing you need to do to start using stencil buffers
after we've set up the stencil buffer
is to set up our stencil buffer. With the setting before setting the video mode.
And then after setting it up, by default, it's in a test mode. It's checking.
Right.
And we don't want to check.
Right.
We just want to draw to it.
Right. So what we need, right. So what we need to do is use our GL. We have two things: GL Sense Func and GL Stencil Op.
And those are the two things we're going to use for controlling
how the stencil buffer is utilized or drawn to.
Just two functions.
Stencil Func is what says, okay, I have the stencil buffer. How do I want to utilize it? For instance, if I just want to completely ignore the stencil buffer, I can simply say GL Always, pass that to GL Stencil Func, and now no matter what's in the stencil buffer.
Get that mouse out. Just saying GL Always. You're going to scare people out there.
Just GL Always.
You can see with GL Stencil Func, we can pass GL Equal, GL Always, and there's several other things as well. And GL Always, if we pass that to it, we can say just always draw to it.
Not draw to the stencil buffer, but always draw to the frame buffer no matter what is in the stencil buffer.
That's what I'm talking about. Right. So you're drawing whatever.
Yep. And if there is something in the stencil buffer and you want to start taking that into account...
In other words, now you want to start doing the testing or the checking.
Right. So let's say if you wanted to, wherever it's white, draw. Wherever it's not white, don't draw. You can say GL equal. So wherever it's equal to, say, 1, it's going to draw to the frame buffer. If it's black, it's not going to draw.
Precisely.
And GL Stencil Op, this is what allows us to set how something is going to get placed into the stencil buffer. So we have things like GL Keep, GL Replace. What those are going to allow us to do, depending on what we pass to Stencil Op, it's going to say, do we want to replace whatever is currently in the stencil buffer? Do we want to keep what's in the stencil buffer?
Right.
So if we don't want to modify whatever's in the stencil buffer, we simply pass to GL Stencil Op, GL Keep.
Right.
For all three of the parameters to it.
Exactly. Kind of a mouthful. At first, looking at this, it can be a bit confusing.
But the code's going to make it all clear.
Yeah, you just got to keep in mind, you've got a stencil buffer, but at the same time, we've also got a frame buffer. You've got to keep that in mind. And in the end, it's what's in the frame buffer that we see. Okay. The stencil buffer is just something in the background that's helping us control what's going to be written to the frame buffer.
Exactly.
And when working with the stencil buffer, we've got a couple of modes that we're going to be dealing with that are pertinent in this case. We're going to rather be writing to it, or we're going to be using it for checking if it's okay to draw a pixel to the frame buffer.
Right.
That's the bottom line.
Exactly.
Okay, so in the next video, what we're going to do is take our simple cube example that, well, I believe we've now left anti-alias.
Yes, we have.
We're now going to take that, and we're going to go ahead and add a floor into that example, and then make that floor appear reflective. So that's going to wrap it up for this video, and we're ready to move on to the next. Thanks, everyone.